In the morning, we have listened to multiple presentations and wonderful panels. We have seen many aspects from how to organize government, how to cooperate between industry, governments, and the academia. And we also see some very great innovative techniques like large language models and amazing data analytics. So I think I don't also want to go to the sewage to measure it. I feel like the sensors robotics are helping us. So, but eventually, all those technologies, all those analysis will go to our end goal for the smart cities to help to improve the life of residents in our cities. So this comes to our sections in the afternoon to try to improve the agile and humane in our cities. So our first speaker is Dr. Wang. She's the founder and director of the Urban Agility and Resilience Lab and an assistant professor of urban and regional planning at the University of Florida. She's a founding faculty member of Fiber within the College of Design, Construction, and Planning. Her research focuses on developing computational tools to measure and manage urban resilience in response to disruptions like hazards and emerging technology. Over the past decade, Dr. Wang has made significant contributions to urban resilience and analytics, particularly in spatial planning and crisis informatives. Recognized as one of the top 5 female scholars in urban analytics, she has published over 40 peer-reviewed papers and secured nearly $2.5 million in research funding, including 7 NSF grants. Her presentation today is Innovating Urban Agility and Resilience. And welcome.
Okay. Thanks, everybody, and great thanks to the IT to get the laptop here so I can present easily. Okay, so it's a great honor to have a presentation today to talk about 3 of my recent projects on urban agility and resilience in face of disruptions. To start, a little bit more about myself. My name is Wang. I am assistant professor at the Department of Urban and Regional Planning at UF. This is my 7th year. I was also one of the cluster hire for Florida Institute for Built Environment Resilience. I direct the Urban Agility and Resilience Lab within Fiber. So my research has been centered on urban resilience to 2 types of disruptions. One is extreme weather and climate events. The other type is more kind of disruptive technologies. So this kind of involves 3 research thrusts. One is to answer how resilience can be measured, explained, and enhanced. The other side is how we can leverage the social media, digital environments, digital social media data sets for more agile hazard response to ensure information equity and also integrity in terms of misinformation and disinformation. So I'm also working on several cross-cutting topics on smart connected cities and climate change and population age and health research. So this is about Fiber. Fiber is more kind of Florida-based research institution, so we do have a lot of community networks across Florida. Each of the core faculty lead a lab within the Fiber, so this is a screenshot of my own lab on agility and resilience. So today I'm really trying to talk about resilience is a key aspect of smart cities, focusing on my 3 recent research projects. The first is on the smart curb for disruptive technologies. Second, on agile event response system for urban safety coordination. And third is on the AI-empowered spatial planning for resilient small businesses. To start this Smart Curb project, we started in 2021. I have a group of collaborators, and also we have fantastic UF partners and also stakeholders from the city of Gainesville. So these projects really to address the challenges of the smart curb environment. So curb kind of serves a very unique nexus that connects both on-road traffic and also the pedestrian sidewalks, but it kind of overlooked. Last study has been done on smart curb and curb environment challenges, but they have growing kind of challenges, burdens in terms of more competing space usages. Think about pickup and drop-off activities. Think about truck loading, and some like e-bike, scooter parking, and some bars kind of stores, right? There's a lot of competing spaces for curb. But there's less kind of research on curb environments. So that's the motivation of the research. So what the NSF Smart Curb project's trying to do is that we try to really gather like a multi-source data from different sources like human sensors, environment sensors, and some citizen surveys, and a lot of different data sources to try to understand what was the kind of localized curb issues that we can address. And then we try to develop more kind of cyber-physical infrastructure for the curb use coordination at the more kind of localized scale. And eventually we want to do more kind of urban scale kind of curb solution to develop a real-time computing and analytical framework to support more new curb management and operations for long-term curb kind of planning. So this is general kind of pathway for this project. So to start the project, we did a lot of data collections and tried to develop smart curb digital twin for city of Gainesville. We used a street imagery data sets to kind of do a lot of computer vision and detect different facilities and curb usages in the town. I'm going to just quickly go through this one. And then we also kind of gather a lot of data sets from the city to identify what was the key issues. So this is just a map of the focused area in downtown Gainesville. We were able to identify very specific curb environment that has some specific challenges there. So we have analyzed data sets like parking occupancies and spatial distribution of the urban amenities, like POI datasets, and also some parking citation datasets that shows different kind of like conflicts in terms of space, time, and the usages. We were also able to try the human behavior kind of pattern to visit and usage these curb amenities and facilities. So integrating these datasets, we were able to develop like a model to kind of simulate under different scenarios what kind of the pickup drop-off opportunities will look like. So basically we try to suggest how the city can allocate more kind of designated PODO zones so to reduce the competing usage of the curb spaces. So this morning I drive from the hotel. I also noticed Coral Gable also have a lot of competing use of the curb spaces, right? So definitely there is a kind of a need for starting this more localized curb events in different cities. So we kind of looking into different scenarios, like if we don't have a designated PDO zone, there is definitely more competing usage of curb spaces. But in some simulation situations, if we just have one designated POD zone, we do realize that competing events have been reduced significantly. So this is from the simulation results. And then so that was more kind of localized treatment for very single kind of curb spaces. But when we think about curb environments, it's actually kind of urban scale challenges. So that requires us to have like an urban scale model to understand the curb usages. So what we do is actually develop like an AI model, deep learning model, kind of connect all these curb usages to integrate the environmental context, different space, curb space regulations, policies, facilities within that graph models, and try to approximate how different kind of contextual factors within that model and also predict different curb uses by different transportation modalities. So this is how the model looks like. Our beta model is more kind of a multi-GCN LSTM. The graph model captures all this kind of spatial proximity among curves and also kind of captures the semantic similarities like curb built environments, curb businesses, policies, some more kind of location-specific facilities. And the LSTM model is more kind of capture the temporal kind of usages for curbs, something like parking and like e-bike parks or some other scooter or even charging activities. So that model also allows a lot of multitask learning to predict diverse curb uses. So we kind of use a calibrated AI model into scenario planning of curb spaces. One is in San Francisco, the other one is in city of Gainesville due to the data availability in the both cities, and they also have very different size. So we evaluate the model and they kind of perform very well. And we even tested the model with different kind of treatment plan just in single curb with different policies, management strategies. The model can pretty effectively predict the spatial spillover effects of the localized treatments. So that helps us in the future to utilize AI in scenario planning. However, we do need more data sets and also kind of ground truth data sets for further validate and calibrate the model for more broader kind of applications. Okay, this is just demonstration about the spatial temporal distribution of the actual and predictive curb uses. So there is like a column of a map showing the actual parking frequencies. There's also like prediction of the parking frequencies. So you can see a prediction actually works pretty well for both scenarios. So we also extend the curbside research, also looking into the EV charging station, because city of Gainesville is really in high demand of developing more charging stations to boost the EV usages. So we develop like more kind of anticipatory planning framework to address 3 challenges of using EV. One is how we actually make the planning more equitable and accessible for both multifamily housing members and also the single-family households, right? So the second challenge is more kind of address the uneven productivity of different EV CS usages, and also to address future market increments, because EV usage kind of change over time. It's not like we can anticipate exactly what's going to happen next year, right? So we want to make it more kind of incremental planning scenario. So I'm not going to talk a lot of details about this project. This has been also in a published paper about the charging station. So another study is really to address the serious challenges we saw in the Hurricane Ian's preparation in Tampa Bay area. There is a big issue in terms of EV charging before the hurricane. There are a lot of people waiting a very long line, a long time for getting charged before evacuation or preparing for the hurricane. So what we try to do is really try to develop like analytical framework to closing the resilience gap of EV charging services for hurricanes. So this specific question, specific research try to answer 2 questions, like what exactly are the factors affect the resilience of public EV charging accesses, right, under hurricane disturbances. And the second question is to help cities and these planners to envision like what will be the resilience gap under the worst case scenario, right? We have been seeing, some city has seen hurricane category 1, category 2, but some have never really met hurricane category 5, right? So we don't really know what's going to happen in the worst case scenario. So we try to really develop a model to help to do some scenario planning under the worst case scenario and see what is the biggest resilience gap under the most significant situation. So that's the purpose of this study. So there is still a lot of ongoing research about smart curb management. So I'm trying to summarize some key ideas here, and we are also keep working on this project. So one is how we actually address curb use equity. So there's a lot of moral and even ethical thinking there, right? Who we should give priority to in terms of curb parking. And the other side is like how we address commuting well-being. I'm not sure how you guys feel like how to park in curb. It's kind of very stressful daily life, right? You have to park somewhere in the urban core to find a parking space. How we could in the future develop something like stress-free for citizens to park in curb areas, right? The second thing is to think about how we better integrate human behavior science to guide the planning, and even for long-term planning. And is there any way like we can develop more agile real-time curb management, considering more evolving contextual factors such as road constructions, such as different extreme weather situation, right? These are all evolving kind of contextual factors that should be leveraged in a smart system. Second thing is how we kind of expanding both macro and micro spatial scale research and growing more convergent social technical research. There is also one challenge because curb currently is managed in a way based on a lot of pricing mechanism, right? We do charge for parking. So we have to seek a balance between a smart system and a pricing mechanism because cities do take some revenues from charging for parking, right? But if we have smart system, what's going to happen with the pricing mechanism for the curbside parking? The last thing is really that motivates us to study the curb use is self-driving vehicles because autonomous vehicle eventually is the major driver of all these pick-up and drop-off activities that happens at the curb space. So we have to think about what's going to happen if we do have self-driving vehicles in the future, how we should design and plan our curb space in the smart cities, right? So that concludes the Smart Curb project. So the next one I'm going to talk about is more kind of earlier research myself since I was a PhD. It is to develop more kind of agile event response system for safety coordination. So it all started with the hurricane response, social media usage, right? We are kind of posting request, help, and some situation awareness kind of posts in social media. But there is no like algorithm at that time, back in 9 years ago, like how we actually detect different types of hazards. So there's a kind of demand like for this kind of a computing system. So what I was doing to make two assumptions. So one is trees related to emergencies can geographically proscate and also semantically related, right? And this kind of emergency usually also trigger very high intensive negative sentiments. So based on these, we were able to kind of detect these kind of geotopic clusters under emergency situation to do some tracking. So it actually worked pretty well in different emergency situations, including I-85, Granville Tower fire, and also the earthquake situations. When we pull it into these kind of geotopic trees, they are all relevant and also very high negative kind of a sentiment associated with that. So along this trajectory of research, we were also trying to keep developing the computing system to enable the tracking of the geotopics besides just detecting it. We try to really detect like what the content's gonna change or evolve in terms of the situations, in terms of the sentiments, also in terms of the spatial spreading of the emergencies, right? How people respond over time. So we kind of leverage the dynamic topic modeling to kind of boost these geotopic tracking models. So that really allows us to actually track the semantic dynamics of geotopics over time, as well as the spatial temporal patterns of how these smaller scale emergency evolve over time. And then we put everything into a real-time system. We try to connect our platform with a real Twitter API. So currently, API is not available, but there are growing social media that allows us, to connect with APIs such as Blue Sky. You probably heard about that, right? So this also to kind of help to connect back to different API to allow us to do the real-time kind of a emergency detection. And this is just a video showing that how it kind of looks like to help emergency responders to pinpoint specific crises and track its changes over time. It's more kind of interactive kind of a geospatial platform. Okay, so moving forward, we also try to maximize the usage of the social media data sets to also looking into the multimodality of data sets. Something like Twitter pictures also says a lot of things, right? Something like short video, something like text message, how we can leverage the multimodality of data sets from social media for emergency response. And one opportunity is really do the damage assessments in real time. So we develop some kind of very better version kind of model to detect different types of the hazard damages relevant to debris, outage, tree fail, infrastructure damage, and even kind of label the severity using the computer vision algorithms. So this was also further being developed into a real-time system. We were able to do like end-to-end architecture that is responsible for data retrieval, analysis, storage, and visualization. It was also able to handle a lot of real-time processing and deep learning tasks through this platform. So this is also just a demonstration of how it works if we do have a lot of environmental sensor data sets, human sensor data sets like social media and some other data sources. The platform can also kind of doing real-time multimodality data processing and identifying all these damaged situations to help more targeted response behaviors. And even for neighbors can help neighbors if this is more kind of public accessible kind of a platform. So there are also some ongoing research following the damage emergency responses. Is recently, especially since COVID, there's a lot of misinformation. So right now I'm working with computer scientists and also several professors from the media and the communication side to looking into the way to mitigate misinformation and disinformation in response to the emergencies. So the information integrity has been like a major challenge right now with social media. So how we actually collectively develop the digital environment norm is another challenge also for planning and other, these other disciplines. So the last project is more kind of a recent research. So from NSF support on how we do the spatial explanation of the planning for resilience of community-based small businesses to environmental shocks. So most of you have experience, right? Hurricane Helene, Milton just happened last 4 semesters, and Ian, right? They all are pretty significant hurricanes to Florida, and even in Miami Beach, I know there's a sunny day flooding, right? Happens most of the summer seasons. It is expected that storm surge is gonna get worse over time with sea level rise. So that's the reality we are dealing with. However, why do I look into small business, right? So we all know this coastal area are kind of a tourism kind of a zones in these coastal cities. But when we're looking at the small businesses and also the chain businesses, we do the comparison, and you do notice that there is a very high significant number of small businesses in storm surge zone A and B, right? But chain businesses are in a safer places, perhaps because some other development history reasons. And local development also are still encouraging a lot of commercial development in the flood-prone areas, right? Due to their significant kind of commercial benefits. So that means small business is gonna be having increasing vulnerabilities, right? If we don't really have effective spatial planning related to land use and transportation to guide them to adapt to these kind of environmental shocks, right? But why small businesses are important? It is a key part of the social infrastructure. Small business is not just something like you buy something, right? It also offers opportunity for people to promote a lot of the community level social connections as a third places besides your workplaces and besides your home, right? That's the places people go, network, exposure to the community environments. But they are also extremely vulnerable in the disaster recovery stage. So these small businesses also depend a lot of the community, local customer visits, especially a lot of recurrent customers. And many of them actually function as a very important social infrastructure for the cities. So that's the reason we think it's very important to look into this. So you probably know that there's a lot of research already out there, right, to study small business, but mainly focus on the capacity of themselves or even the structure kind of a vulnerability of small business. We are trying to looking at this as a planning kind of issues. So another motivation we start this on this planning perspective is that we did an assessment using natural language processing, a kind of earlier version of ChatGPT, right? The AI models to rank 56 Gulf counties plan in terms of how well they address the community-based small business resilience planning. There are several dimensions we did the assessment, like the physical resilience, the financial availability, the social inclusiveness and information accessibility, and even like business operational capacities. From this map, the darker the area got, the better score they have on these dimensions. So actually, you notice that Florida actually did a better job in comparison to Texas, Louisiana, right? But there still are some gaps in very specific dimension in terms of the planning. There is very little knowledge we can find to guide spatial planning for small business, right? It's very kind of economic-driven, localized situation. So we want to do some things to produce more kind of a scientific evidence guidance for this small business in terms of location choice, and try to spatially explain their resilience to these environmental shocks. So the first thing we do is that we don't really looking at the small business itself, its capacity vulnerability, business vulnerability, or the structural vulnerability. What we do is actually sitting from the customer perspective to assess its vulnerability, because this small business essentially depends on the customers. So we try to systematically mapping the vulnerability in terms of their customer catchment and explore the disparities across sectors, across places. That's the first thing we do. And the second thing is try to systematically understand what kind of spatial planning factor contributes to the resilience in their customer visitation, even under the environmental shocks. And the second thing is really to leverage all these big data analysis and the finding to develop a model, anticipatory model, to guide the city and guide them to do better locational choice, planning decisions to help them grow resilience over the long term. So for the the major part of the research really depends a lot of data sets, and some of you probably know about these point of interest visitation data sets, which kind of track the visitation flows from the residential neighborhoods to different point of interest. Point of interest also includes the small business locations. So they are aggregated and fully anonymized kind of data sets derived from the mobile devices panel of 32 million devices, which is about 50% of the US mobile phone users. There's definitely digital divide issues that we should address in the future, but this is so far the best data sets we have access right now for the research. So based on the mobile device trajectory, we are able to track the catchment space of all these small businesses, and we leverage some very mature kind of vulnerability assessment system like social vulnerability index, hazard vulnerability index, to collectively assess the vulnerability of the customer catchments, and to assess the 70 coastal metropolitan areas in Florida, and you can see the results here. And we also do find like coastal fringe trap in all these kind of metropolitan area, is that the area between the most close to the coastal area and the inland area that serves as a transitional fringe zone that has the highest vulnerability across all the space and the sectors. So the next thing is we looking at all these almost 500,000 small businesses in the 28 counties and try to quantify their resilience based on their kind of resilience trajectories over time. We did a meta-analysis framework to explain resilience with spatial factors. So with this functional clustering, we were able to retrieve different typology of the resilience of different types of small businesses. And we try to kind of seek the linkages between the spatial factors and also the resilience findings. So last thing we do is actually a better version AI model on Cape Coral that we actually want to use AI model to help the planning process. There's a better version to do that. We use a team to do the CSV acclimation detection, and then we have a graph attention model to rewrite the gravity model to advance the existing physical model to kind of predict the resilience over time. So that also help us to in the scenario planning, but more research needs to get done on this direction of work. So in general, I think for the future research, we do need to really integrate both big data and the small data, because small data is a way opportunity we gather digital divide populations inputs, And we do need a better training data of cities. Sometimes it's not the direct process. We probably have to use augmented data sets to avoid the propagation of pre-existing spatial disadvantages. This was also addressed in the prior presentation this morning. The other thing is an opportunity to really think about theory-informed urban AI for more robust performance, right? Because AI always have this kind of overfitting issues. We also need more kind of responsible AI for spatial planning with more human in the loop to make sure it's kind of a transparent and responsible process. And finally, to move forward, this whole field to address real problem is really requires a lot of multi and cross and transdisciplinary kind of collaborations with stakeholders and different disciplines. So that concludes my presentation, just very practical, very small scale projects, but hopefully that's something helpful for the discussion. Thank you so much.